Hello, hi, I'm Punita here from Huawei Global Training Center, and today we're going to discuss about the content eNodeB radio data part 15. So let's look into LTE mobility management overview. So what is mobility management? It's mainly related to handover concept. So this is divided into idle state and connected state. So for idle state, basically what will happen during the idle state, cell reselection will happen. During the connected state of the RRC, handover will happen. So handover and redirection. Redirection is related to PS redirection. So handover is divided into three categories. So we do have the intra-frequency, we do have inter-frequency, and we do have inter-rad frequency. So intra-frequency is same band, inter-frequency is different band, inter-rad is different technology. So this is the neighboring cell overview. So we have eUtran intra-frequency neighboring cell, eUtran inter-frequency neighboring cell. Intra is same band, inter is different band. We have CDMA if you have that kind of product. eUtran's neighboring cell is 3G cell, and GRAN neighboring cell is related to 2G cell. So eNodeB can be neighbor to a 2G base station, 3G base station, CDMA, and another eNodeB. So these are the command related. So let's look into the handover scenarios. So we have coverage-based handover. We have intra-frequency, inter-frequency, and inter-rad. So for intra-frequency, what is the measurement trigger? After the radio barrier is established, the eNodeB delivers an RRC connection reconfiguration message containing the measurement configuration to the UE. For inter-frequency and inter-rad, the eNodeB delivers the measurement configuration when the service quality in the serving cell is less than a specific threshold. So they will base on the event. So you need to do some reporting. So based on that, they will do the coverage-based handover. For load-based handover, the measurement triggered by the mobility load balancing. So this is depending on the load balancing algorithm. Frequency priority-based handover, this is only applicable for inter-frequency. The eNodeB delivers measurement configuration when the service quality in the serving cell is greater than the specific threshold. For service space is for inter-rad and inter-frequency. So after the initial contact setup request is processed or a barrier is established, modified or removed, the eNodeB determines the service status of the UE. For uplink quality base, it's applicable for inter-rad and inter-frequency. So the eNodeB triggers the measurement after it detects the unsatisfactory uplink quality. So this is based on the uplink quality to the UE. Then the handover will happen. SPID based handover back to home PLMN. So this one has two categories, inter-frequency, inter-rad. So when you admitting a new UE, handing over a UE from another cell, or admitting a UE after RRC connection re-establishment, the eNodeB will query the SPID information delivered from the EPC side. They will check whether the PLMN of the cell work on the highest priority or not, and whether it's same as the serving cell or not. So if not, the eNodeB will trigger the inter-frequency or inter-rad measurement on the frequencies with higher priorities than the frequency of the serving cell. So this has more checking to be done, and a little bit more complex as well. Distance base is for inter-frequency and inter-rad. The eNodeB will trigger the measurement after it detects the timing advance value. So the eNodeB triggers the measurement after it detects the timing advance value reported by the UE exceeds a specific threshold. Then only it will decide on the distance base. So there are many kind of handover scenarios here. So let's look into the commands. Set handover switch. So modify the cell algorithm. So this command basically modify the settings of the cell level algorithm switch. Switches from handover on load, frequency priority, and distance to be set. So when you modify, you can see this algorithm switch is based on distance or frequency or probably blind handover and etc. So let's try to look into this command. So I'm going to list the cell algo switch. So we're going to see what kind of handover we are using here. So this is the cell algo switch parameter. So they have many parameters here. So basically this one will indicate what are the switches activated and what are the switches which is not activated. So this is load balancing algorithm switch, TCP, downlink power control, uplink power control. So basically we have the uplink IC switch. This is beamforming scheduling switch. So handover is also part of this configuration. So when you modify the cell algo switch, so there are many categories here. All right. So this is basically the handover. So this is distance based handover. This is frequency priority based handover. So depending on which handover you are using in your network. So this is where you will set up the commands, the settings for the handover. So next, modify the eNodeB algorithm switch. So this one will modify the handover based on coverage, services, uplink service quality can be set. So basically when you modify the eNodeB algo switch, you will set the handover based on the interfrequency, service based or uplink quality based. So let's look into this command. So modify eNodeB algo switch. So we have the handover switch here, interfrequency, U-turn, GRAN, uplink quality. So everything is available here. So this is where you will configure the required handover mode that you are going to use. So this is what we have discussed earlier. So you can do the settings from this command. Uplink quality, interact. Uplink quality, interfrequency handover switch. So this is an example. And here you will activate some other switches as well. So this is the command for the external eUtron cell. So add eUtron external cell. So this is only for the neighbors. They have the PCI and they have the tracking area code. So let's look into this command if there is any neighbors into our together with our LTE network here. So list eUtron external cell. So for this particular site, we don't have any neighbors. So let's look into the second base station. So I'm going to repeat the same command. So this is the example of the command, but there is no neighbors for our site here. So next is eUtron intra-frequency neighboring cell. So you're going to add a neighbor into together with your same band neighbor. All right, intra means is same within the same eNodeB, or it could be the same frequency band. All right, so let's look into this command, intra-frequency neighbor cell. So it's going to be eUtron intra. So this one is intra-frequency neighboring cell. So within the same band. So there isn't any configuration, but this is an example of the command executed. Next, we go into the interfrequency neighboring cell. So this one is actually for interfrequency neighbor, different band. So similar information you need to fill up. It's just that you need to permit handover to a different band. Okay, let's look into this command. So this is going to be interfrequency neighboring cell. So there isn't any example, but this is how the command is executed. eUtran interfrequency neighboring cell. Q&A session. So the eNodeB delivers measurement configuration when the service quality in the serving cell is less than a specific threshold. The statement is true. So the summary of this section is that we have learned about LT mobility management overview, neighboring cell overview, handover scenarios, how to set handover switch, how to add external eUtran cell, how to add an intra-frequency neighboring cell, and how to add an interfrequency neighboring cell. That's all from me. Hope you enjoyed the session. Thank you and bye.